6. 2, 6. This is only part of it. The other part is composition of functions. You can call this operations on functions for the whole section if you want. So let's start someplace simplistic. For you, lucky you're not in like pre-calculus or something else, for you there's only 2 things to worry about. Thing number 1, you cannot divide by 0. You cannot divide by 0. That's just a guarantee. Number 2, you cannot square root a negative to come up with a real solution. You cannot square root a negative number. That's it. If something is not doing either of these, you can do anything you want, as long as you're not dividing by 0 or square rooting a negative number. So if I ask you a silly question like, what is the domain of f of x is equal to 3x squared minus 2x plus 5. What would your answer be? Without looking at a graph of it, how would I know what the domain of this is? Well, the questions go back up to here. 2 things you cannot do. Am I ever going to divide by 0 by plugging in x into this function?
Say that again.
Am I ever going to divide by 0 by plugging in x into f of x? Heck no, it's not going to happen. You're never going to divide by 0. Am I ever going to take the square root of a negative number in f of x? Can't do that. I'm going to be plugging in real numbers and it's going to generate real numbers. So the domain of this thing is from negative infinity to positive infinity. You will find all polynomial functions have a domain of negative infinity to positive. You can plug in anything. You can square any number, you can multiply any number, you can add any number, you can subtract any number, and you can divide any number, except you can't divide by 0. But there's no division here. It's just powers, addition, and subtraction, and multiplication. All right, so if you run across a function that is a polynomial, you all know what polynomials are, right?
Yes.
You know, 5x to the 5th minus 3x squared, anything that's whole number powers, you're perfectly fine. The domain of those is going to be all real numbers. So that leaves the rest of them. What other types of functions are there? How about something that looks like this? For example, find domain of f of x is equal to 4x minus 5 divided by x squared minus 9. Now I go back to my 2 things to worry about. Is it possible, by picking a value of x, that I'm going to divide by 0?
Yes.
Yes. Why? Because there's x's in the denominator. And anytime there's x's in the denominator, I've got to really worry about x being equal to something that causes a 0. How do I find out when they are? Well, you take the denominator and you set it equal to 0. So you go x squared minus 9, set it equal to 0. See what happens. How do I solve that? You can. Keep going. I'm just curious if you'll get the right answer.
And then square root both of them.
And you get x equals?
That's 3.
And then I say, please don't do it that way. Factor.
Huh?
Factor. X plus 3, x minus 3. You all said that the answer was 3, right? 3 and negative 3. Because you square root both sides of an equation, what do you have to tack in?
I see what you're doing, alright.
If you square root both sides of an equation, what do you have to tack in?
What?
Plus or minus. If you forget that, you're going to lose one of the answers. So here we get x is equal to 3 and negative 3. Alright, but here's a problem. I don't want x equal to 3 or negative 3 because that causes a 0 in the bottom. So we're going to say the domain of this function is x cannot equal cannot equal 3 or negative 3. But all other numbers are fine. Now, I don't usually write that bottom part, but when you say x can't be those two numbers, you're saying that it's just those two numbers. All the other numbers work perfectly fine. The book will write it this way. Negative infinity, negative 3, parentheses, union, negative 3 to positive 3, union 3 to infinity. And that notation is really long and trivial. All it's doing is jumping negative 3 and jumping positive 3, leaving them out, but it's all the other possible numbers. I'd rather you just write it the way I wrote it. X does not equal 3 or negative 3. What about the top? Do we care about the top? It's irrelevant. It's there for decoration. All right, how about this one? Find domain of g of x is equal to the square root of 4 minus 3x. Things to worry about. Am I ever going to divide by 0?
No.
No. And you really do need to come back to these two things, because it's possible that you're doing both. And that's when people usually make mistakes. So I'm never going to divide by 0, so I don't have to worry about denominators equaling 0. Am I ever going to take a square root of a negative number?
Yes.
It's possible. What do I want to make sure that 4x minus 3 is?
Positive.
I need this thing to be positive. Now this is the difference between finding a denominator set equal to 0 and getting rid of them, and talking about this one opposite of what I wrote over there. Over there I said you cannot take the square root of a negative number, but you definitely can take the square root of a positive number. So you take the 4 minus 3x, to make it positive, what kind of inequality? I don't want to do absolute. That forces it to be positive. I want to just choose it so it is positive. Not equal to 0, greater than. I want it to be anything greater than 0. Now, here's my last little question. Can it equal 0? Can you take the square root of 0?
No.
Can you take the square root of 0?
Oh, I guess yes.
We talked about that earlier when we were graphing it. Square root of 0 is just 0. So we can also have it be equal. So positive or 0. And that's exactly what I wrote down there. 4 minus 3x is positive or 0. That's all it says in English. All right, let's solve this inequality. Subtract 4, you get negative 3x is greater than or equal to negative 4. Divide by negative 3, and you get x, and don't forget to flip your sign, is less than or equal to 4/3. So the domain on this g function, I'm going to write it this way, so we don't get confused with that one over there. The domain on the g function starts when? Interval notation-wise. Smallest number possible.
Negative infinity.
Negative infinity. All the way up to 4/3. What kind of symbol goes next to it?
Bracket.
Bracket, because it is
Stops right there.
equals. Because it is equals. And there's your domain of your g function. You can pick any number from 4/3 off to the left. Negative 5, negative 10, negative 100, whatever. Just as long as you don't pick 2. Because watch what happens when you pick 2. 3 times 2. 6. 4 minus 6. And now you're taking the square root of a negative number. And you can always test your interval if you want to make sure you got it going in the right direction. You know, pick a number that's not in your interval and make sure it doesn't work. If it does work, then you went the wrong way. All right, how about something a little more complex? Let's call it h of x is equal to x plus 1 over the square root of x plus 2. X plus 1 over the square root of x plus 2. Let's ask the questions in order. Am I ever going to divide by 0?
Yes.
Yes. When am I going to divide by 0?
And
When x is
negative
negative
2.
2.
When x is negative 2. So right off the bat, I know that x cannot equal negative 2. That's one of my first things I look at. That's usually the easier of the two questions. The second question you have to be careful with. Am I ever going to take the square root of a negative number?
Yeah.
Heck yeah. So that means I have to take whatever's inside, come down here and say, well, I want x plus 2 to be greater than or equal to 0. What do most people do? They do exactly the same thing as fractions. They set it not equal to 0. You got to keep those two things kind of separate. Whatever's on the inside has to be greater and equal to 0. All right. So this, after we solve it, becomes greater and equal to negative 2. Now we have a problem. The top one says x cannot equal negative 2. The bottom one says x can equal negative 2. So guess what we have to get rid of? No.
Oh, the negative 2?
No.
The pop?
Just the equals. I can't have this equals here. So instead of greater than equal to 0, this really has to be just strictly greater than. So this has to, by putting these two together, it has to become x is strictly greater than 2. So the domain of this h function starts where? At 2. Where does it go? Positive infinity. Parentheses on the right. What about the left? Parentheses, because it doesn't have a equals. So that's the domain of that function. It's like pulling teeth. All right. What else can we do to you? Ooh, I got 5 minutes.
Homework.
Oh, no. I don't waste 5 minutes on homework.
No, God forbid.
I got a quick question. How do we know that it's infinity?
Huh?
That's a longer question.
Because this inequality says if x plus 2 is greater than 0, any number greater than 0, it'll work. So when you solve it, you get down to this x is greater than 2. Well, what's greater than 2? 3, 4, 5, 6, 7, and off to
Gotcha.
infinity.
I got you.
Okay. Let's go back to this word combining. I'm not going to be able to finish it, but I can at least start it. Combining functions. Let's say, what do they call that? Not profit, revenue. Let's say we have a revenue function, and our revenue function looks something like, oh, I don't know, x squared plus 4x minus 5. Revenue. Y'all know what revenue is?
Is the money you get
It's how much money comes in.
comes in?
That's not talking about how much money goes
Um,
out. So let's let c of x
your cost.
be my cost function and let it equal x squared minus 7x plus 4. And this will be cost. How much it costs to run a business. And let x equal number of widgets sold. Y'all know what a widget is, right? A widget is an imaginary thing that a company makes. Seriously, there's no such thing as a widget. It's just
What was
something.
that from the? No, that was the worldwide.
Oh no, I don't know why. There are now phones things, but a long time ago, widgets were how business schools were like, okay, we're going to make a bunch of widgets and make a profit off of them, and widgets would just be an imaginary
Whatever
thing.
you decide.
Yeah. But now they're
I'm giving it a worldwide wicker company. Never mind.
all right. So I want to find profit.
Oh, we're going is a word problem almost.
Yeah, not really if you think about it. How do you find profit if you know your revenue and cost?
Add them up.
No, you don't add them.
Subtract them.
One's the money coming in. The other one is money going
Out. So
out.
you subtract
So
them.
you subtract them. So to find profit of x, you're going to take your functions, and it's actually written this way. Which is weird. This is the notation you have to get used to. But this actually means
Yeah.
r of x minus c of x. It has nothing to do with the distributive property. It has nothing to do with the distributive property. This is just fancy notation to say these two functions are working on the domain of x. These x's have to be exactly the same. You can't make them different. You can't have 5 over here and 3 over here. That makes no sense. So by writing it this way, you're forcing your two functions to work on the same domain. So these are your functions, And this is your common domain. You cannot have them working on two separate domains. That's really, really important. They have to work on the same domain. Therefore, I said X is the number of widgets they made. So it's, you're putting the number of widgets they made into R, you're putting the number of widgets that they made into C, you're taking your two answers and subtracting them. So our final answer is going to be, well, R of X is X squared plus 4X minus 5 minus, and this minus sign is that one I always warn you about. This is the one you really need a parentheses for. X squared minus 7X plus 4. And then you simplify, and you get this, well, the X squares cancel. 4X minus a negative 7X. That's 11X. Negative 5 minus 4? Negative 9. So this R minus C function, evaluated at some widget number, is the same thing as our profit function. And this is all that combining functions is. It's taking these two ideas and either adding them together, subtracting them, multiplying them, or dividing them. And the notation is real simplistic. If the book writes this, the book will write that. You don't leave it like that, because that makes absolutely no sense. So what you do is you write it as the first function evaluated at X plus the second function evaluated at X. We'll talk about domains of them next time. That gets a little weird. If they write F minus G of X, then you write F of X minus G of X. It's very simple. But don't leave it in this notation. Instantly transform it over to something that makes a little bit more sense. If they write Fg of X, what do you think the operation is? Multiplication. So you go F of X times G of X. And this is the one you have to worry about. F divided by G of X. And why do I have to worry about this one?
Because you get confused.
No.
Division.
Because there's division. Is there a possibility that I might divide by 0?
Yes.
Yes. So here you have to be a little bit cautious. G of X, we definitely do not want him equaling 0. That's probably the only weird one. The plus, the minus, and the times, we only have to worry about the domains of the original functions. But the division, you have to worry about that bottom also can't not equal 0. So if the book throws these at you, you transform them right away into the other stuff, and then do your work. But generally, most people get those right. Hey, perfect. All right, domain and range. Don't divide by 0. Don't take square roots of negative numbers. So I want to expand on that and talk about something like maybe, if we have f of x is equal to 4x over x minus 4, and g of x is equal to the square root of x minus 2, then how would we find f minus g of x?
Okay.
Good late morning to you.
That's not late. I've been up since 5 o'clock.
Well, I highly suggest, you're going to do that, but I would suggest that you rewrite this as f of x minus g of x to get it out of the function notation and into individual functions. So then f of x becomes 4x over x minus 4. G of x is the square root of x minus 2. Now, the only thing that's really hard about this, because generally, all you have to do is add, subtract, multiply, or divide functions.
Wait a minute.
What?
Never mind.
Okay. So the hard part of this is not going to be actually doing the operation. The hard part is the second part of my question, which is, what's the domain of this new function?
4, 2.
Now you got to be careful. You have to kind of go by pieces. What do you mean by 4?
Okay.
What is the domain of that piece?
Is x cannot equal 4.
X cannot equal 4. So over here we get x cannot equal 4. How do I deal with this piece?
X can't equal 2.
X can equal a lot of things.
Okay. You have to.
That one you do not say not equal to. That's only for fractions. For this one you say greater than or equal to.
2. Negative 2.
Oh, well, the equation I want, though, is x minus 2 is greater than or equal to.
X minus 2?
Uh-huh.
Square root of x minus 2?
What kind of number does x minus 2 have to be?
A positive.
Positive number. And to make it positive, you set it greater than or equal to?
Absolute value.
No. Set it greater than or equal to? No.
0.
Thank you. Because when you're greater than or equal to 0, what kind of number are you? Positive. So you take x minus 2 and you set it greater than or equal to 0. When you solve it, you get x is greater than or equal to 2. Now, when you're doing this combination of functions, no matter what operation it is, addition, subtraction, multiplication, division, you have to take the two domains and bring them together as one. So this one says you definitely cannot use 4. This one says you can only use numbers bigger than or equal to 2. So when I write the domain of this function, where does it start?
In the 4.
It's definitely not negative infinity.
4.
2.
It's at 2. So it starts at 2. Where does it stop?
Infinity.
Nope.
4.
4. It has to stop at 4 because it can't be equal to 4. So it stops at 4. It does a little what's called a jump. And it starts up at 4 again and goes off to positive infinity. That's where those get tricky because you have to figure out the domain from what is given. Do you want more?
Yes, I really.
How about f of x is equal to the square root. I gotta think about this for a second. 4 minus x. G of x is equal to the square root of x plus 2. And I want to find f plus g of x. You'll see that I avoid multiplication with radicals because that actually gets a little more tricky and we're not going to go in that direction. And its domain. And of course, the harder part of this is the second part. Its domain. All right, so when you see f plus g of x, the first thing you should write down is f of x plus g of x. So the easy part is this is going to equal the square root of 4 minus x plus the square root of x plus 2. That was the hard part. Good. Now once you get the pieces in place, you start with the domain, and you just find the domain of each one of the little pieces. So what is the domain of this first piece? Take the inside, whatever. You want to keep the steps exactly the same. What did we do with this radical over here? Took the inside, set it greater than or equal to 0. Don't change things. Just keep doing the same thing over and over again. So 4 minus x is greater than or equal to 0. Therefore, negative x is greater than or equal to negative 4. Therefore, x is less than or equal to positive 4. And we get the domain for that one. Over here, for this square root of x plus 2, you take the x plus 2 and you set it greater than or equal to 0. And you get x is greater than or equal to negative 2. So if we put these two domains together, what are we talking about? Negative infinity to positive infinity?
No.
I doubt it, because if you try negative 1, even negative 1, you can't do it here. It has to be able to be plugged into both of them. So if you can't plug it in here, you can't plug it into the whole thing. So what numbers can I plug in? You said it backwards. Well, it's negative 2. Negative 2 to 4. You have to. I mean, this becomes a number line if you wanted to. Here's negative 2. Here's positive 4. This is a closed circle pointing this direction. This is a closed circle pointing in that direction. It has to work for both functions. So where do I look on this number line graph? Where there's two lines. So the only places that have two lines where it works in both of them is in between. So the domain is from negative 2 to positive 4. Ta-da. It's not hard, it's just you have to think about what you need. A combination of both domains. Alright. So combining functions, not too bad. Composition of functions, that's something different. That's another beast entirely. Now this one you're going to have to revisit some topics that we've dealt with before. Alright, you work at a small store. They're having a 15% off everything sale. That means there's a ton of people in your store, which is a pain to begin with. And the sales tax is 8%, and your cash register just broke. Do you close the store?
Yep.
Sure.
Yep.
Sure, if you want to. If you own the store, you're going to close it. No, you own it.
Oh, okay.
You own it, because if it was you, yeah, you'd go home and not worry about it. But this is a profit-making deal for you. So you can't close the store, and all you have available is a 4-function calculator. And you have to figure out all of these things. How much it costs for the items, the 15% off, and then the tax. So if we do it individually, we're going to come up with, for our purposes, we're going to come up with a sale function. Now, the first thing off is the value of the items coming to is going to change. Since it's going to change, we're going to let that be a variable. We're going to call that x. And we've done this before, earlier in the semester. So how do I find 15% off of x dollars? X times 0.15, and then what?
Subtract what you get from the price.
So tell me algebraically what should I write?
X, let's see, x minus 0.15 equal.
No. What do you do with the 0.15? You multiply it by? No.
The price.
Which is?
X.
Which is x. So this would be my sale function. Let's call it g of x. Alright, so if we simplify this, g of x is equal to, this is where I worry about our school free education system. What's x minus 0.15x? 0.85.
How'd you get in?
Because there's a 1 here. If you have $1 and I take 15 cents away from you, you have 85 cents left. Like I said, this is where I worry about our free education system.
Don't be so worried about it.
I am super worried about it.
I was about to say, if you're so worried about it, go to another state that's gonna do it then.
Then I wouldn't have a job.
So then don't worry about it.
But I do worry about it because eventually you're going to be out on your own.
Is there a state that doesn't have a free education? Is there a state in this country?
No, they're all free. They're all free. Now we need a tax function. Tax function. So how do I find tax on x dollars? We're not going to go to the 0.85x. We're going to go right to the original price, which is x dollars. So how do you find tax on x dollars?
It's gonna be X.
Why do people say minus?
It's time.
What happens with taxes? They go and take your bill and make it
Higher.
bigger, not smaller.
So it's x plus 85.85.
No.
The original price, which is x. 0.08.
0.08 times.
X.
Alright, this is going to be our f of x. And f of x, if you simplify, it becomes equal to
1.08.
1.08 times x. Alright. So this your store owner here which you're kind of pretending is you, went through all this and got these two functions. Great. So let's now use them. Someone came up to the cash register with $120. So we're going to let x equal $120. So the first thing he would do is go, oh, I'll have to figure out the sale price of it. And that would be 0.85 times 120. Now you all have calculators, I hope, so what's this equal to? What is it? $102. So the cost of the items has been reduced down to $102. Now he has to turn around and find tax. So what does he do? No. Use the functions.
So it's going to be 1.08 times 102?
Well, the first thing he's going to do is plug it into the other function. And you're going to get 1.08 times $102. So the final cost at the register for $120 is?
$110.16.
$110.16. So he does two calculations and he gets to his final answer. That's actually pretty quick if you think about it. Instead of doing all these little pieces over here on the left, he can just do two calculations. But I want to do something better. Did you notice what happened here? You plugged it into one function, took the answer of this function, and plugged it into the other function. That's a composition of functions. Anytime you do a calculation, take that answer and put it into another calculation, you're taking two functions and actually putting them together. So what happened here is you actually found out what f of g of 120 is. Yeah, we're getting to fog. We're getting to fog. So what if I wanted to do this in one calculation, one fell swoop? Well, I could figure out what this is in comparison to x. So what if I did f of g of x? Now function notation says this. The outside function, all you have to do is take whatever's inside the parentheses and shove it in. So I'm going to substitute g of x into any position in f where there's an x. What does f look like? Where's f? There it is. 1.08 times x. So I'm going to rewrite this as 1.08 times something. Times something. And what I'm going to plug in there is exactly what it says to, which is?
120?
No. G of x. I want to plug in this. So what's g of x look like? 0.85x. Okay. Now, what is 1.08 times 0.85?
0.918?
0.9, exactly. 0.18 times x. Now here's the cool thing. Ready? Find me f of g of 120. In other words, over here, you're going to substitute x and replace it with 120. I guarantee when you multiply these two together, you get $110.16. So what the store owner now can do, instead of doing even just two calculations, he can do one and get every one of those customers out of his store really quickly. And later go back and figure out what the tax was for the government. But it's a neat idea. You take two functions and bring them together as one, so you're only doing one calculation. All right, so now let's talk about notation.
Do we have to do it like that, or you were just showing us?
Ooh, yes, you have to do it like that. I don't show for fun.
Yes.
No, I don't. Notation. Now, the notation is not super important, so the important thing is to be able to convert it into our normal function notation. So the book and a lot of other places, they will write it this way. This is called fog notation. Why? Well, because it looks like it spells the word fog. When you see this notation, keep everything in order and rewrite it in function notation. So the little operator here between f and g is not times, it's actually called composition. So this is f composed with g. And to write f composed with g, you write it as f of g of x. So basically all it is putting a function inside of another function. It can be repeated this way. That's called Goff. But you're going to write it as g of f of x. Now the funny thing about this notation is it kind of works a little funny, so you have to be careful. The biggest mistake on a test is I will ask for f of g of x, and students will give me g of f of x. So you got to be careful. They're not commutative. Not like addition and multiplication. They do not commute very well. Not for all functions. Those two it actually does. So for example, if I give you f of x is equal to 2x minus 3 and g of x is equal to x squared minus 9. Just some random function. Well, by the way, what's the domain of f of x?
Can't equal
Can equal 3 perfectly fine.
Any real number?
Any real number. Why?
Because there's not a 0 in the denominator.
There is no denominator.
I mean,
And there is no
square root.
square root sign. Since there is no denominator and no square root, it is all real numbers. You can plug in anything you wish. It's a polynomial. Okay, so I want to find f of g of x. I'm going to write it as fog of x. Again, if you see f of g of x written that way, rewrite it in function notation and realize what you're seeing here. What's getting plugged into what? No, don't say function notation-wise. Don't even look at the functions themselves. In this notation, what is getting plugged into what? G of x is getting plugged into f. So what function should I worry about first? No. F. I need to know what I'm plugging into. I know what I'm plugging in. I'm plugging in g of x. What I'm plugging into is f. So you go to your f function. What does f look like? Well, it's 2x minus 3. If I'm plugging into it, it's going to become 2 times something minus 3. What's the something? X squared minus 9. So that goes in here. And then all you have to do is simplify. So this becomes 2x squared minus 18 minus 3 minus 21. And this is f of g of x is equal to 2x squared minus 21. Basically all this is saying is, if you knew what x was equal to, well, no, don't worry about that. We'll get back to that in a second. What if I want to find g of f of x? Do you think the answer is going to be exactly the same?
No.
More than likely not. So this is really g evaluated at f of x. What function do I concentrate on now? The g function. So you write down what the g function is minus the x's. G looks like something squared minus 9. Remember I told you to replace those letters with parentheses all the way throughout the semester? This is the main reason why. This topic right here. What goes inside the parentheses? 2x minus 3. So you get 2x minus 3 in here. Ooh, this one's a little messier. We have to square that out. So, 2x squared minus 3 all squared. 4x squared minus 12x plus 9 minus 9. That's all I have to write. And that's your answer.
So you don't have to,
Well, it's plus 9 minus 9. What happens with plus 9 minus 9?
no, I didn't, I'm not talking about that. You don't want to factor out an x?
Is there anything that's going to simplify? Am I going to cancel with anything? There's no point.
Yeah, wait, can you, like, would you just do, you just FOIL?
Yeah, you FOIL this out. It's going to be 2x times 2x, and then 3 times 2 twice. That'll give you negative 6x, which is negative 12x. And then negative 3 times negative 3 is positive 9, but you have a minus 9 here, it'll cancel. It'll zero out. Alright. What if I want to find f of g of 1? without looking at my f of g of x down there. Let's say we didn't even have that available. Well, this one becomes a little different. You have two choices. You can go search for f of g of x, which would be perfectly fine. Come up with 2x squared minus 21, plug the 1 in and get your answer. If you don't have that available, though, you could do g of 1 first. That's going to be a value. G of 1 is equal to some number. So how do you find g of 1? So what's the g function look like? Where is it?
Squared minus 9.
Something squared minus 9. What goes inside the parentheses? 1. 1 squared minus 9 is equal to? Negative 8. And then take this answer and go back and plug it in here. So this will turn into f of g of 1 is equal to negative 8. So f of negative 8. What's the f function look like? That's, where is it? There it is. 2 times something minus 3. Negative 8 goes in here. 2 times negative 8 is? Negative 16 minus 3 is better known as negative 19. And you can see that it actually works because 2 times 1 is 2. 2 minus 21 is negative 19.
So the answer for that last one would be negative 8, negative 19?
The answer to this one, after you calculate it, is negative 19.
So that's the final answer.
And if you want to talk about a coordinate, the coordinate would be 1, negative 19. Because the x value up here was? The 1 at the very beginning. Are these things always easy? Heck no.
So the final answer, or never.
The final answer is this.
No, not there, for the other problems.
Oh, the final answer for this one is this.
Okay.
And the final answer for this one is this. Where do they get hard? Well, with the domains again. So for instance, if I have f of x is equal to 2x over x plus 1, and g of x is equal to 4 over x minus 5. Ugly rational functions, horrible. What if I want to find g of f of x? Goff. Oh, did you notice the difference between the way these things work? If you have an x involved, you work on the outside function first and plug in the inside function. If there's a number involved, you start with the inside function and eventually get back to the outside. So x's you go backwards, numbers you go inside out, x's you go outside in. So be careful with that. So g of f of x, what function do I want to concentrate on? The g. So I'm going to write this function down, except wherever there's an x, I'm going to replace it with an empty set of parentheses. Don't worry about what it is until you go back to the problem and say, oh, it's got to be f of x. So what goes inside the parentheses? 2x over x plus 1. You have to stop here. Don't keep simplifying and forget to stop here. There's a reason you need to stop. You have to look at what you just plugged in and say, what the heck is the domain of that green thing? What is the domain of that little green piece that I just plugged in? This has to be part of your final domain. Since x cannot equal negative 1 there, it cannot equal negative 1 through the rest of the simplification. So it has to be part of the final domain. Now we're going to simplify. What kind of fraction is this? Complex. How do I simplify a complex fraction? Multiply everything by?
Conjugate. It's conjugate. It's not, that's
It's a complex fraction. Conjugates work with radicals. Complex fractions, you multiply everything by?
the opposite.
The common denominator. What's the common denominator here?
Really?
Yes, what's the common denominator here?
X plus 1 minus x minus 5. I mean minus 5. X plus 1.
What's the denominator of 4?
1.
1. What's the denominator of 5? What's the common denominator?
X plus 1.
X plus 1. It's the only one in the denominator. X plus 1. He's a 1, he's a 1. That's an X plus 1. So you multiply everybody by X plus 1. Now the only place it gets interesting is this first term on the bottom. What happens to the X plus 1s? They cancel. That's the whole reason for doing it. The top becomes 4x plus 4 after you distribute the 4. The bottom becomes this 2x. Now be really careful. What's the next part become?
5x
No.
minus.
Negative 5x minus 5. That negative has to distribute to the x and the 1, so be careful.
I had it written down, but I just said it wrong.
You just don't say things correctly.
I don't.
Now we can simplify the bottom a little bit. So this is 4x plus 4 over negative 3x minus 5. I mean, that's decent, but I would never leave it that way, personally, but you could leave it that way. G of f of x is equal to this mess. Do you want to know how I would write it? Sure. I would write it this way. What did I do?
The negative sign.
I distributed the negative. I took the negative out of the bottom and I gave it to the top. It's safer to have negatives in the numerator than in the denominator. Oh, we're not done with that yet. I haven't finished the problem because I haven't stated its new domain. So when we state the domain, we have to be careful. We already know one part of the domain. X cannot equal negative 1. But we've got a fraction down here also. It doesn't matter which one you use. We'll use this one here. What has to be true about this bottom?
You can't.
Can't equal 0, so negative 3x minus 5. Find out when it is equal to 0. That's when x is equal to negative 5 thirds. Because you'd add 5 and divide by negative 3. So when you get down to the domain, it's x cannot be two numbers. It cannot be the one we found way up here, which is negative 1. And it cannot be the one we found down here, which is negative 5 thirds. And that would be the completion of the problem. I found my composition, and I found the domain that is related to it. Isn't this fun? You don't think so?
I don't enjoy it.
I like it. I've always liked compositions. Shoving one function inside of another. We can go backwards with this stuff. It's called decomposition.
We need to get the composition first.
The composition isn't that bad. If you go to my idea of replacing your variables with empty sets of parentheses and just shoving in what's there, life is easy. Decomposition says, I'm going to give you this h of x function, and I want you to be able to break it up into an f of g of x. I want you to break it up into two functions that are composed with each other. So if I give you h of x is equal to the square root of x minus 2, what you want to look at is what is inside of this function and what is the outside function. So inside is usually kind of easy. What's inside? X minus 2. Make that your g of x. So you come down here and you say, oh, well, g of x must be the inside thing, which is x minus 2. What that leaves for f of x is this. Write the square root symbol. That's what's left of the h of x. And where there was an x minus 2, what should I put? Now think of this. I'm going to compose it. So if I was going to take the x minus 2 and plug it into f, it would have to go into an x. The x would be replaced with parentheses. Well, where did parentheses come from? It came from an x. So f of x is equal to the square root of x.
That's it.
That's it. What? Think of it this way. If I took these two original functions and I said, oh, let's find f of g of x, what would you do first?
Let's find out.
Ignore the black stuff up there. Just look at the blue stuff. If I want you to find f of g of x, what function would you look at first? F. You would take the square root of x and replace the x with parentheses. So you'd write the square root of something, and inside the something would go g of x. G of x is x minus 2. So you get back to the original h of x. I'll do it again.
That's how we check it.
Decomposition. Pulling the functions apart. How about something uglier? H of x is equal to 3 times x plus 1 all squared minus 5 times x plus 1 minus 7. And we want to write this as the f of g of x. So the first thing you do is you say, oh, well, g of x must be the inside function, which is, take a guess, x plus 1. And then what you do is you take what's left over and you leave it for f of x, which is 3 times something squared minus 5 times something minus 7. What's the something in this case? X. So f of x is 3x squared minus 5x minus 7. So if you do f of g of x, you end up at h of x.
Alright, where's the curveball?
There is no curveball.
Where's the 1 at?
Where's the what at?
The 1.
I took it away when I said, here's g of x. I yanked out x plus 1. So I go through with my eraser and I erase the x plus 1 because it got yanked away.
So now you're left.
And then what I'm left with is a bunch of empty parentheses. Well, those empty parentheses come from x when we do function things. If I want you to find h of x is equal to x squared minus 2x plus 3, what is the first thing I say when I do x plus h? Not h. X plus 2. How do you find h of x plus 2?
Put the X.
No. What is my first step?
Oh, rewrite it with parentheses.
Rewrite it with parentheses. So anytime you're left with an empty set of parentheses, they originally came from x. That's all I'm doing here. H of x is equal to the square root of x minus 2 plus 7 divided by x minus 2 all squared minus 5. You need to look at it the right way. Compositions are functions going inside of other functions. What looks like it went inside?
X minus 2.
X minus 2. So you'd say g of x is our inside function. It's equal to x minus 2.
Alright, we pulled out X minus 2, so we are.
Erase the x minus 2s.
Erase them for them. Erase the X minus 2.
There you go.
And this gonna be the
But that's why I'm writing it like this. The square root of plus 7 over something squared minus 5. Remember, these long bars are actually parentheses. What goes inside the parentheses? X. If you get it, you get it. If you don't, I can't help you. Because that's not that hard.